Okay, all you college tour folks, here is a lesson that you missed, lesson 2.1. It starts with stuff that you should know or should remember, but you may not. If you want to find the distance, you want to use the distance formula, which is d equals the square root of x2 sub 2, that's not a squared, that's a designation as the second point, minus x sub 1 squared, plus y sub 2 minus y sub 1 squared. Now when you have a point here, these are ordered pairs. We know that points are always x and y. Points are x and y. However, we're going to call one of these points point 1 and 1.2. So I'm going to call this point 1 by saying x1, y1, and this is point 2. I'll say x2, y2. And so those are now my y1 value, those are my x1 value, and so forth. So I'm going to plug into the formula. So x2 minus x1, I basically say you're looking at these two values right here. My computer is stalling on me. It's not letting me change pens. There we go. It's a little bright right there. Okay. So we have x2 minus x1 is 3 minus, I'm taking this, minus a negative 3. Minus a negative 3 squared. Now when you minus a negative, that's an awful lot like boom, boom, adding a positive. And then plus y2, which would be 1, minus negative 4. Again, subtracting a negative is a lot like boom, boom, adding a positive. So we get square root of, let's see, 3 plus 3 is 6. 6 squared is 36. Plus 1 plus 4 is 5. 5 squared is 25. And so we've got that. It's going to be equal to, see, 50, that's 61, square root of 61. So that's the distance of this graph. So if I look at the point negative 3, negative 4, big picture, what we're trying to do is find the distance between these 2 points in 3, 1. That's the point 3, comma 1. And that's the point negative 3, comma negative 4. So I'm finding this distance. Notice we couldn't just kind of eyeball it. We couldn't say, oh, I'm going to try to count these out. Oh, it's not going to work. You've got to use the distance formula. There is another way you could do it, just to show you. If you wanted to, you could actually draw a right triangle here and count out this side. 1, 2, 3, 4, 5, 6. Count out this side, it's 5. And you could use the Pythagorean theorem. You could say 6 squared plus 5 squared is equal to c squared. So that's 36 plus 25, which is 61, is equal to c squared. Take the square root of both sides. Do I have to put plus or minus right here? I don't think so. The reason is we are talking about a distance here. And so since this distance is, the distance is square root of 61, or approximately 7 point something. And we also need to know how to find the midpoint. And so you probably want to know the midpoint formula, which is the midpoint, we'll just call midpoint x comma y, is going to be the sum of x1 plus x sub 2 all over 2, comma y1 plus y sub 2 all over 2. And that's basically, actually a lot of my students who remember this long term, they really just remember it this way, this idea. They say, okay, what's the average x, comma, what's the average y? Because isn't what you're doing here? You're adding up two numbers and divided by 2. That's finding their average. So all you're doing is really looking and finding the average x and finding the average y. So if you look at the two x values, right? That's what we're finding here, the average x. What's the average x between the two of those? So 3 plus negative 3 is 0. 0 divided by 2 is 0. So my x value of my midpoint is going to be 0. Let's add up to two y values. Negative 4 and 1 adds up to negative 3. Half of negative 3 is negative 1.5 or negative 3 halves, however you want to write it. So 0, negative 1.5. My graph, if I drew a straight line, would probably go right through that midpoint there at 0, negative 1.5. So you need to know both of those formulas. Make sure to memorize those. So you got a question like this, and you have a point here, 2 comma negative 1. That's point A. 4, negative 2 is point B. And 5, 5 looks to be up here. That's point C. I'll try to draw a little straighter that line this time. So I'm going to connect these points and make a polygon of sorts here. And we're trying to figure out if this is a right triangle or not. This is what it says. Does it form a right triangle? It says use the distance formula. It's kind of a hint for you. I could eyeball it and kind of guess that it might, in fact, form a right triangle, but we really need to actually go a step further and use the distance formula really 3 times. So this first time here, I'm going to find this distance AB. So I'm going to say distance AB is going to equal the square root of, and let's start writing this out. So this is going to be, let's see, A, B are these 2 points. That's going to be 4 minus 2 squared plus negative 2 minus negative 1, which is really like plus 1. So we get 2 squared, which is 4, plus negative 1 squared, which is 1, which is a grand total of square root of 5. Distance of this side is square root of 5. Let's find another distance. Let's do AC. So this distance here. So A and C, I'm looking at these 2 points. Distance AC is going to be square root of, whoops, that was weird. Square root of, let's see, A and C, so 5 minus 2 squared plus I know what I was doing. My arm is hitting the button that makes it go to the right here. So that's what was happening there. Took me a second to figure that out. Okay, 5 minus negative 1, which is really like 5 plus 1 squared. When you simplify that, that'll be 3 squared, which is 9, plus 6 squared, which is 36, which is square root of 45. I could simplify that to like 3 square root of 5, but I'm just going to leave it like that for our purposes right now. And finally, I want to find this side, the distance CB. So distance CB is equal to square root of, let's see if we can do this a little quicker. So we're looking at CB, this one and this one. So 5 minus 4 is 1 squared, plus 5 minus negative 2, which is 5 plus 2, which is 7 squared. We get a total of 1 plus 49 is square root of 50. So this side is square root of 50. Now I know all 3 sides, but that doesn't prove anything yet. And so what we really need to do is apply Pythagorean theorem. A squared plus B squared equals C squared. If I plug in these 3 values and it makes that statement true, then I have proven this is in fact a right triangle. So I know that this one has to be C if it is in fact a right triangle, because it's the biggest side. C is always the biggest. So I'll put these interchangeably at A and B there. So square root of 45 squared plus square root of 5 squared equals square root of 50 squared. And that statement is true. 45 plus 5 is 50, and so that works. So we proved it was a right triangle. What is the distance between these points? Well, if you think about it, negative 3, 4, negative 3, negative 2, you could use the distance formula, but just a distance of 6. 1, 2, 3, 4, 5, 6. If you do distance formula, you'd have negative 3 minus plus 3, which is 0 squared, plus 6 squared, which is the square root of 36 is 6. And so you get the same answer algebraically as well. This is just to help you kind of process this new information here that you're about to learn. So this is what we've done in the past. We have an open circle at -3, arrow to the right. That's what this graph looks like. This problem looks very similar. I'd say there's a difference though. I don't know if you notice this part. What this tells us is the graph is not going to be just a number line. What it tells us is that actually it's going to be a graph. And so I know my answer is going to be an XY graph. It's going to have X and Y ordered pairs. What's one order pair that makes that true? Well, I think there's probably a point right here. 1, 1 would be true. I think there's a lot of points that would be true here. Really, if you think about this graph, instead of an open circle, it's going to have a dotted vertical line, an asymptote, at -3 there. And then I'm going to shade. X is bigger than -3. Just when this one's shaded to the right, really all of this is part of my solution area. Any point, doesn't matter which point I pick in here, 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 even points in between here. Any point I pick anywhere to the right of this vertical line where X is bigger than -3. So it doesn't matter how big Y is. Y can be 6, Y could be -4. It could be way up there. It doesn't matter what Y is. But as far as the X is concerned, it must be bigger than -3. It's very similar. We know it's a graph because it looks like that. It's on that Cartesian plot there. And Y equals -2. Well, I don't know if you caught on, but you see X, this is going to be a vertical line. When it's Y equals, it's going to be a horizontal line. So Y equals -2 looks a lot like this. It's a straight line at -2. And that is our graph. There's no shading because there's no inequality there. It's just an equal sign. Let's try this one. As soon as you see Y, let's look at that part of this. Y is less or equal to 4. Let's see, it looks like a horizontal line. At 4, Y is bigger than -1. So Y -1 looks like this, but I think it's going to be dotted. And Y is sandwiched in between the two, and so the shading is going to be in between the two there. And this one's kind of the weirdest question of all of them almost, which is what points would make that true? And so it's basically saying X times Y. This is just telling you it's a graph here. Two numbers multiply to make a positive number is what this is saying. Well, anything in this quadrant, the X and Y terms are going to be positive and positive. So I would say that everything in this quadrant makes this statement true. It'll be positive. This quadrant is going to have a negative and then a positive. If you look at the X and Y values, multiply a negative and a positive, you do not get a positive. That is not part of the solution. Negative times negative, yes, that is part of the solution. And finally, positive times negative in this quadrant, and that's not going to be part of the solution. I would probably add some dotted vertical lines, dotted vertical line, asymptote there, and asymptote there as well. But that is your graph. Last question. So we've got two different inequalities. Let's graph this one. You should get the hang of this. This is a vertical line at 2. And then this one is a horizontal line at -2. Now, notice what happens here. We're going to have some graphing. So X is bigger than 2, so everything to the right of this is shaded. And then everything to the, or below -2 is going to be shaded. So everything down here is shaded. I don't know if you see this, but is there any area that you see that is double shaded? Well, I see an area right here. And so that area is going to be our solution. I would just shade it extra dark when you do this, because this is an and, so we're looking at the overlap of the two. Goodbye.